Hi everyone, I'm Tasnia,
I'm Shreya.
I'm Hasata.
I'm Yafi.
and this is our CSCE 606 project called LEAT Planner. If you could go to the next slide, please. So our project is built for all Aggies or Texas A&M students, but we specifically built this with CSC department students in mind or anyone looking to get into the software engineering industry. So primarily, the app is used to plan or track study times, but we also have a special feature for tracking how many leak code problems students are practicing in a week. And our motivating problems for this are number one, students have a complicated relationship with discipline, and two, it takes a lot more time to finish a problem than it should, ideally. So our core features could be grouped into three. First of all, to make the app to give the app a more holistic approach to time tracking and time management, we have a Google Calendar integration so students can view all their weekly commitments and add and edit events directly from our app. But again, we have a LeetCode integration so they can group LeetCode problems with those study sessions that they plan. And three, we have a weekly digest so that students could get a weekly overview and track their progress from time to time. So I'm gonna pass it on to Hasita.
Hi, I'll be talking about the system architecture overview that we used for this project. We built our application using Ruby on Rails framework, following the MVC design pattern to ensure a clean separation of concerns and scalability. The user interaction is with the system via a web browser, which sends requests to our Rails backend. The application responds with dynamically generated content using ERB templates in the views layer. A backend architecture is using controllers, which basically coordinate between views and models. And our models are directly interacting with our Postgres database to perform CRUD actions. Shreya, can you move on to the next slide, please? So here you can see that our architecture design and also the external integrations that we are using. We are using Google OAuth to secure user authentication and also Google Calendar APIs to provide calendar-based features. For communication, we use Mailgun for a reliable email delivery service and to receive weekly reports. The database that we are using is PostgreSQL. Um, right, and as you can see here, the technologies and tools that we use are Google OAuth, Google Calendar, Mailgun, open source APIs for LeetCode, and PostgreSQL for data storage. Yeah, we are using PostgreSQL because it's an advanced open source relational database, and it's very scalable and reliable. The entire system is deployed on Heroku with separate environments for staging and production. And this is our database design. We have users and LeetCode sessions and problems, so we can track how many problems have been solved by the user in a given session. These were the earlier UI mockups that we had created for our app. As you can see here, this is our calendar and the LeetCode page that we had thought to implement earlier. I'll hand this over to Yafe now.
Okay, here we highlight the core building blocks of our web app. First, the model defines data structure like user profile, legal problem, and session schedules. Second, the controller manages requests and connect model with the views, ensuring smooth interaction. Finally, the views use ERB template to render responsive and user-friendly pages. Together, these three layers form the foundation of our Rails application. The dashboard is our study command center. It automatically starts a countdown timer for any scheduled sessions, helping users stay focused during study time. Here is also a manual timer for ad hoc practice sessions, so user can track productivity even outside scheduled events. This feature sets the tone for structure and mindful study routine. Next, we have the calendar and LeetCode integration. The calendar sets lets user create, edit, and delete event directly in our app, syncing instantly with Google Calendar. In the LeetCode page, user can filter problems by difficulty or tag, then attach them to study sessions. This integration connects time management and problem-solving practice seamlessly in one place. Finally, our statistics page summarizes each user's weekly progress. It shows problem solved, total attempts, and current streaks, with a highlighting of the week's best performance. This helps users visualize their improvement and stay motivated to keep learning consistently. Overall, these features make our app not just a tracker, but a personal coach for consistent growth. I will hand it to Shreya.
Yeah, the same statistics that Yafe talked about, which can be viewed on our application, can also be configured to be received on a user's email ID. So we send out weekly emails about their progress. So they have like two ways with which they can track their statistics. The LeetCode username with which for which we need to pull the user statistics, as well as the personal email ID on which we need to send these statistics reports, can be configured on the profile page in our application itself. So overall, all of these features that we just talked about, the dashboard, which shows the time events, whether scheduled, unscheduled, the calendar, the lead code, and the user profile itself, they're all geared towards making sure this whole lead code preparation process for our users is as smooth as possible. But if we look at things on the other hand, how it was for us as developers to put this whole thing together, perhaps the development process was not as smooth, because first of all, Ruby on Rails was something that was new to all four of us, so we had like a very steep learning curve with which we try to familiarize ourselves with the different technologies, also with the testing frameworks, whether it was Cucumber for acceptance tests or RSpec for unit tests. But that also taught us how we need to be mindful of the time that's spent in coming up to speed with new frameworks and new technologies while we're planning and allocating time for different development activities in our sprints. Uh, During our development process, we also struggled with different sort of problems, and one major one that we've given here as an example was how we configured Google OAuth and how we manage sessions in our applications. So we encountered frequent problems where our users would keep getting logged down and the session state would not be maintained. And it took a lot of back and forth and coordination between different members of the team to figure out how to isolate and then resolve these problems. So we relied on AI tools like Gemini, Copilot, ChatGPT, as well as the good old Stack Overflow and documentation by Google itself to figure out what these problems are. And then that helped us hone our critical debugging skills, which can come in handy for future projects. The final challenge that I would like to talk about is the lead code data itself. So we plan to scrape this data from lead code, but they don't have any public free use APIs that we could use for this purpose. So we explored open source AI APIs that would help us do that. But these also had very limited use in the free tiers. So for future, maybe we thought that we should have a more formal vetting process for any third-party APIs we're planning to use, or we could consider implementing those from scratch and accordingly allocate time and bandwidth for that in our sprint planning. I'll hand this over now to Tasnia for our future plans.
So going off of what Shreya was saying, aside from the problems that we've experienced, we've also had a bunch of improvements that we would like to implement in the future. For example, if we had more resources and time, we would have implemented a lot more statistics. For example, we could implement the amount of time spent for LeetCode problems instead of just the number of problems solved per week, or the number of types of problems that we tend to do better in, the number of attempts for each problem, etc. And also we could track the amount of time spent outside of the app to track break times. To add to that, we wanted to make our app more functional and just a better workspace for focus. So we could have added like lo-fi music or some study music in the background to help students focus. And we could have expanded our reach to other learning platforms like Canvas instead of just using LeetCode. And last but not least, if we had more time, and resources, then we would have made our interface more intuitive so that users could log more study times with less clicks. Next slide, please. And to end it, we would like to acknowledge that we have utilized AI from time to time while working on the project. Like Shreya was saying, we did have a lot of unexpected issues, and we did consult AI to debug those problems. We also use Gemini to generate our UI mockups, and we have also used AI for help with generating some of the boilerplate front-end views and just tedious tasks that require lots of copy and paste. So that's it for our presentation. Thank you for listening.